Hello, math learners! Our lesson for today is about hyperbola as conic section. Let us have the learning objectives. You are expected to define a hyperbola and its parts. Determine the standard form of the equation of a hyperbola. Convert the general equation to standard equation of a hyperbola and vice versa. Sketch the hyperbola on the Cartesian plane and solve real-life problems involving hyperbola. This is the Learning Pocket Concept Map. And we are going to tackle the different forms of equations of the hyperbola, the parts, graphs, and applications of hyperbola. Let us have hyperbola as conic section. A hyperbola is the intersection of a right circular double cone with a plane at an angle greater than the slope of the cone. This is the illustration of a right circular double cone with a plane intersecting an angle greater than the slope of the cone. And the intersection is what we call the hyperbola. A hyperbola is the set of points in a plane whose distances from two fixed points, called foci, has an absolute difference that is equal to a positive constant. In other words, if points F1 and F2 are the foci and D is some given positive constant, then the coordinates xy is a point on the hyperbola if D is equal to the absolute difference of D1 and D2. In this illustration, the segment from this point to this point minus the segment from this point to this point is equivalent to 2a, where a is the distance from the center to the vertex. Next, let us have the parts of the hyperbola. You have the center, the vertex, another vertex here, focus, you have another focus here, you have the co-vertex, another co-vertex. This segment is what we call the conjugate axis. This segment is the transverse axis. This is the latus rectum, another latus rectum. You have the directrix, another directrix. Let us have the key points of the hyperbola. The center is the midpoint between the two foci. The hyperbola intersects the focal axis in 2 points called the vertices. The axis that contains the foci, the center, and the vertices of the hyperbola is referred to as focal axis or the principal axis. A segment passing through a focus of the hyperbola that is perpendicular to the focal axis is called the latus rectum. A pair of lines that is closely related to but also not part of the hyperbola are the asymptotes of the hyperbola. The directrix of a hyperbola is a straight line perpendicular to the transverse axis of the hyperbola and intersecting it at the distance away from the center. A hyperbola has 2 directrices spaced on opposite sides of the center. The transverse axis is a line segment that passes through the center of the hyperbola and has vertices as its endpoints. The foci lie on the line that contains the transverse axis. The conjugate axis is perpendicular to the transverse axis and has the co-vertices as its endpoints. The auxiliary rectangle and the asymptotes are helpful in defining the extent of the hyperbola. And the transverse axis will always have the length of 2a and the segment of length 2b that is perpendicularly bisected by the transverse axis is the conjugate axis. Let us have now the general form and the standard form of the hyperbola. If the center is at the origin with coordinate 0, 0, the transverse axis is x-axis. The general form is ax squared minus cy squared plus f equals 0. The standard form is x squared over a squared minus y squared over b squared is equal to 1. If the center is at the origin and the transverse axis is y-axis, the general form is cy squared minus ax squared plus f is equal to 0. And the standard form is y squared over a squared minus x squared over b squared is equal to 1. If the center is not at the origin, represented by hk, and the transverse axis is x-axis, the general form is ax squared minus cy squared plus dx plus ey plus f is equal to 0. And the standard form is the square of x minus h over a squared minus the square of y minus k over b squared is equal to 1. And if the center is not at the origin, which is also represented by hk, and the transverse axis is y-axis, the general form is cy squared minus ax squared plus dx plus ey plus f is equal to 0. And the standard form is the square of y minus k over a squared minus the square of x minus h over b squared is equal to 1. Let us have an example. Convert the equation in general form into standard form. The given is 9y squared minus 16x squared minus 144 is equal to 0. For the solutions, all you have to do is to transpose the constant, which is negative 144, to the other side. So you have 9y squared minus 16x squared is equal to 144. And you have to divide both sides of the equation by 144. Then simplify 9 and 144, 16 and 144. So what you have is y squared over 16 minus x squared over 19 is equal to 0. And this is now the standard form of the hyperbola. So again, the standard form is y squared over 16 minus x squared over 19 is equal to 1. Example number 2. Convert the standard equation into general form. The given is the square of y plus 4 over 9 minus the square of x minus 1 over 36 is equal to 1. For the solutions, first, you have to find the LCD of 9 and 36, which is 36, and you have to multiply each member of the equation by the LCD. So, it would be like this. And then, after this, the result now is 4, because that is 36 divided by 9 is 4. And you copy the square of y plus 4 minus 36 by 36 is 1. So, what is left is the square of x minus 1. So, just copy. And then 1 times 36 is equal to 36. And then you have to expand this part and also this part. So, you have now 4 times the quantity of the square of this is y squared plus 8y plus 16 minus the square of this is x squared minus 2x plus 1 equals 36. And then simplify. So what we have is you simply distribute. So 4y squared, 32y, 64y, and this is negative x squared. This is now positive 2x and negative 1. Then transpose 36 to the other side. So you have negative 36 equals to 0. And then rearrange. So what we have is 4y squared minus x squared plus 2x plus 32y plus 64 minus 1 minus 36 is equal to 0. And then simplify further. So what you have is 4y squared minus x squared plus 2x plus 32y plus 27 is equal to 0. And this is now the general form in simplest form. So again, the general form is 4y squared minus x squared plus 2x plus 32y plus 27 is equal to 0. Next example. Convert the general equation into standard form. The given is 25x squared minus 9y squared minus 50x minus 18y minus 209 is equal to 0. For the solutions, you have to regroup first the terms and transpose the constant. So we have 25x squared minus 50x minus 9y squared minus 18y is equal to 209. Then apply common monomial factoring. So the common of 25 and 50 is 25. Take it out. So what is left is x squared minus 2x. And you give a space for the third term because later on we have to complete the square. Then for 9 and 18, the common factor is 9. So take out 9. So what we have, 9y squared divided by 9 is y squared. Negative 18y divided by negative 9 is positive 2y. Then you leave a space for the third term. Is equal to 209. And then by this time, you have to complete the square. Supply the third term. So the third term of this is 1. That is 2 divided by 2 is 1. Square 1 is 1. Next here, 2 divided by 2 is 1. Square 1, so it's 1. And you add also the other side by 1 with a multiplier of 25 here plus negative 9 as the multiplier of this trinomial times 1. And then factor the perfect square trinomial. We have to factor this trinomial. We have x minus 1 times x minus 1. Here we have y plus 1 and y plus 1. And then express the binomial factors as square of binomial. So we have 25 times the square of x minus 1 minus 9 times the square of y plus 1 is equal to 2 to 5. Simplify 25 and 2 to 5, 9 and 2 to 5. So what we have is the square of x minus 1 over 9 minus the square of y plus 1 over 25 is equal to 1. And this is now the standard form of the hyperbola. So again, the standard form is the square of x minus 1 over 9 minus the square of y plus 1 over 25 is equal to 1. Next, let us have the hyperbola with center at the origin. Let's take up first the horizontal hyperbola with center 0, 0. The equation is in the form of x squared over a squared minus y squared over b squared is equal to 1. Where the formula for c is equal to the square root of a squared plus b squared. And c is greater than a. To find the vertices, you have to follow this formula. Positive or negative a, 0. For the foci, positive negative c, 0. The equation of the transverse axis is y is equal to 0. The location is on the x-axis. And the length of the transverse axis is 2a. The endpoints can be taken by positive or negative a, 0. For the conjugate axis, the equation is x is equal to 0. The location is on the y-axis. The length is 2b and the endpoints of the conjugate axis, we have 0, positive or negative b. For the latus rectum, the equations, we have x is equal to positive or negative c. The direction is vertical. The length can be computed by 2b squared over a. The endpoints can be taken by having these coordinates, negative c plus minus b squared. The endpoints can be taken by this formula, negative c plus minus b squared over a and c plus minus b squared over a. For the intercepts, we have positive negative a. For the x-intercepts, we have positive or negative a. For the y-intercepts, none. Asymptotes can be computed by y is equal to plus or minus bx over a. Directrices, we have x is equal to plus or minus a squared over c. And for the graph, we have this. This is the center. The distance from here to here is equivalent to a. So this point is negative a, 0. Distance from the center to here is a, so this point is with coordinates a, 0. From the center to this point, this is the foci, it is c, 0. Because from center until here is equivalent to c. And also with this, from the center to here, it's c. So it's negative c, 0. And from center to here, that's the value b, so it's 0b. From here to here, it's 0, negative b. And these are the endpoints of the latus rectum. These are the endpoints. This is the directrix, another directrix. And the intersecting lines are the asymptotes of the hyperbola. Let us have an example. Find the coordinates of the foci and the vertices and the endpoints of the transverse axis, conjugate axis, and latus rectum of the hyperbola x squared over 4 minus y squared over 5 is equal to 1. Let us have now the values. The given equation is in standard form. So x squared over 4 minus y squared over 5 is equal to 1. So the value of a is 2 because the square root of 4 is 2. The value of b is 2.24 since the square root of 5 is 2.24. And the value of c is 3 because square root of 4 plus 5 is the square root of 9 and the square root of 9 is 3. So what we have for the vertices, since a is 2, so one vertex is with coordinates 2, 0 and the other is negative 2, 0. For the foci, c is 3. So we have 3, 0 and negative 3, 0. The equation of the transverse axis is y is equal to 0, which is on the x-axis. And the length is 4 units because 2 times 2, which is the value of a, is 4. The endpoints of the transverse axis are the same with the coordinates of the vertices. For the conjugate axis, the equation is x is equal to 0. And the location is on the y-axis. The length is 4.48 units because that is 2 times 2.24. And the coordinates of the endpoints are 0, 2.24 and 0, negative 2.24. The latus rectum equations, we have x is equal to 3 and x is equal to negative 3. Direction is vertical. The length of the latus rectum can be taken by 2 times b squared, and b is 2.24, square it, and over a, which is 2, so the result is 5 units. And for the endpoints, just simply substitute the values of C, B, and A and simplify. Then what we have is negative 3, 2.5, negative 3, negative 2.5, and 3, 2.5, and 3, negative 2.5. For the intercepts, it's positive, negative A, so we have 2 and negative 2. And for the y-intercept, because it will not cross the y-axis. For the asymptotes, just substitute the value of b and the value of a. So what we have is y is equal to 1.12x and y is equal to negative 1.12x. For the directrices, just substitute a, then square it over the value of c. So what we have is x is equal to 1.33 and x is equal to negative 1.33. So let us have the graph now. Plot now the center, the vertices, then mark the transverse axis. You have the co-vertices, then draw the conjugate axis, then draw also locate the foci, intersection of the points, then locate the endpoints of the latus rectum, then draw a segmented line for the latus rectum, then draw the asymptotes as well as the hyperbola and also the directrices. And do not forget to label properly the graph with its coordinates. And for the solutions of the general form of the equation of the hyperbola, so given the standard form x squared over 4 minus y squared over 5 is equal to 1, the solutions would be multiply each member of the equation by the LCD of 4 and 5, which is 20. And this is now the form. So 20 by 4, that is 5. 20 by 5 is 4. 1 times 20 is 20. So you have 5x squared minus 4y squared is equal to 20. And equate to 0, so the general form is 5x squared minus 4y squared minus 20 is equal to 0. Next, let us have the vertical hyperbola with center at the origin. So, if the center is at 0, 0 and the foci on the y-axis, the equation now is y squared over a squared. So, take note the denominator of y now is a squared. The denominator of y squared is a squared now, minus x squared over b squared is equal to 1, where c is equal to the square root of a squared plus b squared and c is greater than a. So for the vertices, by this time we interchange the position. Instead of having a as the abscissa, by this time we have 0 and the ordinate now is positive, negative a. For the foci, we have 0 and positive, negative c. For the transverse axis, we have x is equal to 0. The location is on the y-axis. The length is 2a. Endpoint 0, positive, negative a. For the conjugate axis, the equation is y is equal to 0. The location is on the x-axis. The length is 2b. The endpoints, we have positive, negative b is equal to 0. For the latus rectum, y is equal to positive, negative c. Direction is horizontal. The length of the latus rectum is the same, 2b squared over a. Endpoints, by this time we have positive, negative b squared over a. negative c, and the other one is positive negative b squared over a with positive c. By this time, x-intercepts none. Y-intercepts, we have positive negative a. Asymptotes, we have the equation y is equal to positive negative a over bx, and directrices, we have y is equal to positive negative a squared over c. So this is now the graph. This is the center, but this time the hyperbola is drawn in this manner. So this is now the center, and you have now the vertex. This is now the vertex on the y-axis. So this is now the transverse axis. The co-vertex is here now and here. And this is now our conjugate axis. And the latus rectum is from here until here. This is our focus, another focus, and another latus rectum. Identify the intersection points so that you can draw your auxiliary rectangle. So this point and this point, the intersection is here. This point and this point, the intersection is here. So from here and here, this is the intersection. From this point and with this point, this is the intersection. Connect this point and draw the line. That's your first asymptote. This point and this point, you draw a line passing these 2 points here, and you have another asymptote. And this is now the equation of the asymptote. And this broken line here are the directrices. This one. Next. Let us have an example. Find the coordinates of the foci and vertices and the endpoints of the transverse axis, conjugate axis, and latus rectum of the hyperbola y squared over 36 minus x squared over 64 is equal to 1. So, by substituting the values of a, which is 6, b 8, and c is equal to 10, these are the corresponding values, where the coordinates of the vertices, we have positive 0, positive 6, and 0, negative 6, or 0, positive or negative 6. For the foci, 0, positive, negative 10. Equation of the transverse axis is x is equal to 0, located on the y-axis. The length of the transverse axis is 12 units. The endpoints is 0 and positive, negative 6. Equation of the conjugate axis is y is equal to 0, location on the x-axis. The length is 16. Endpoints is positive, negative 8. Equations of the latus rectum, we have y is equal to positive, negative 10. Direction, horizontal. The length of the latus rectum is 21.33 units. The endpoints, we have positive, negative 10.67 and negative 10, and positive, negative 10.67, 10. Y-intercepts, we have positive, negative 6. The asymptotes, we have y is equal to positive, negative 3x, or you can convert it into decimal, positive or negative 0.75x. For the directrices, we have y is equal to positive, negative 3.6. So for the graph, so this is now the center. From here, going up, that's the value of A, that is equivalent to 6 units. So from this point until here, it's 6 units. This is 2, 4, 6. So from the center until here, this is the other vertex. So we have the coordinate 0, negative 6. From here, this one, it's the co-vertex. So that's 2, 4, 6, 8. Here, we have the coordinates negative 8, 0. Find the intersection points of the vertices and the co-vertices. So we have here this point, this point, this point, and this point. Then from this point to this point, you draw a line, and that's your asymptote. This point and this point, you draw a line passing these points. This is the other asymptote. And this is your focus, another focus. You draw a line passing through the focus, that is the latus rectum. And these are the endpoints of the latus rectum. And this is the focus. You draw a segmented line. This is the latus rectum, endpoints of the latus rectum. And you draw this segmented line to represent the directrix, which is y is equal to negative 3.6. The other one is y is equal to 3.6. And the equation of the asymptotes, we have y is equal to negative 3/4 x, and the other one is y is equal to 3/4 x. Next. Let us have now the standard form of the equation of a hyperbola with center HK. Let us focus first on the horizontal hyperbola. The equation is the square of x minus h over a squared minus the square of y minus k over b squared is equal to 1, where c is equal to the square root of a squared plus b squared and c is greater than a. For the vertices, we have the coordinates h plus or minus a, then k. Then for the foci, h plus minus c, then k. Transverse axis equation is y is equal to k, direction is horizontal, the length is the same, 2a. Endpoints, we have h plus minus a, k. For the conjugate axis equation is x is equal to h. Direction is vertical, the length is 2b. Endpoints is h and k plus or minus b. Latus rectum equation is x is equal to k plus or minus b squared over a. Direction is vertical, the length is 2b squared over a. Endpoints is h minus c and k plus or minus b squared over a. And the other one is h plus c, k plus or minus b squared over a. For the asymptotes, we have y is equal to k plus or minus b over a times the quantity x minus h. And for the graph, we have this one. So the center now is not at the origin. This is the center, the vertices here and here, focus, focus, co-vertices, co-vertices, then draw the asymptotes, then you have the latus rectum, and you have the hyperbola. So by this time, I did not include the directrices because the graph is already crowded. You may or you may not include the directrices. Next. Let us have an example. Find the coordinates of the foci, vertices, the endpoints of the transverse axis, conjugate axis, latus rectum, and the other parts of the hyperbola given the square of x minus 1 over 16 minus the square of y minus 2 over 9 is equal to 1. So, following this formula, for the equation, the square of x minus 1 over 16 minus the square of y minus 2 over 9 is equal to 1. The value of h is 1. The value of k is 2. The value of a is 4 since the square root of 16 is 4. The value of b is 3 since the square root of 9 is 3. And the value of c is 5 because c is equal to the square root of 16 plus 9, which is equivalent to the square root of 25, and c is equal to 5. So all you have to do is to substitute all these values to the corresponding letters here. So for the vertices, we have h plus or minus a, then k. So h is 1 plus minus 4 for a, and then 2. Then simplify. So what we have, 5 and 2, and negative 3, 2. So you do the same. So for the foci, we have 6, 2, negative 4, 2. For the equation, y is equal to 2. Horizontal for the direction. For the length, it's 2 times 4, so it is 8 units. For the endpoints, then we have 5, 2, negative 3, 2. For the equation, x is equal to 1. Vertical is the direction. Then 6 units for the length of the conjugate axis. Then the endpoints, we have 1, 5, and 1, negative 1. Equation of the latus rectum, we have x is equal to positive or negative 4. For the direction, it's vertical, 4.5 for the length of the latus rectum. And the coordinates, we have 6 and 4.25, 6, negative 0.25, and negative 4, 4.25, negative 4, negative 0.25. For the asymptotes, we have y is equal to 2 plus minus 3/4 times the quantity x minus 1, or 3x minus 4y plus 5 is equal to 0, and 3x plus 4y minus 11 is equal to 0. And this is the graph of the given hyperbola. So this is now the center, so it's 1, 2. And this is the vertex, another vertex, focus, another focus. Endpoints of the latus rectum. This one, endpoints of the latus rectum. And the latus rectum is approximately equivalent to 4.5. So it's here. 1, 2, 3, 4, and we still have excess here, so it's approximately 4.5. And these points are the intersections of the vertices as well as the co-vertices. Then you draw a line passing through this point and this point. This is your first asymptote. This point and this point, this is your second asymptote. And do not forget to label the graph properly. As I said, you may include the directrix, or as I said, you may include or you may not include the directrices. And in simplifying the asymptotes, the equation y is equal to 2 plus or minus 3/4 times the quantity x minus 1. First, you have to transpose 2 to the other side. So what we have is y minus 2 is equal to plus or minus 3/4 times the quantity x minus 1. Then, for the positive part, we have y minus 2 is equal to 3x over 4 minus 3/4. And then, you multiply each member of the equation by the LCD 4. So, what we have is 4 times y is 4y, 4 times negative 2 is negative 8. Cancel 4 here, so what we have is 3x. 4 and 4 here will be cancelled, so what is left is 3. And then transpose 3x here, so we have negative 3x, copy 4y, copy negative 8, transpose negative 3, so it's positive 3, equated to 0. Then, you can simplify the signs. So, multiply each member of the equation by a negative 1. So, what we have is 3x minus 4y plus 5 is equal to 0. That is why we have here 3x minus 4y plus 5 is equal to 0. And for the other one, we have y minus 2 is equal to negative 3x over 4 plus 3/4. So simplify. So multiply each member of the equation by 4. So we have now 4y minus 8 is equal to negative 3x plus 3. Then transpose this. So we have positive 3x, just copy 4y, and negative 8, transpose positive 3. So we have negative 3 equal to 0. So what we have is 3x plus 4y minus 11 is equal to 0. So it's here. This line is the 3x plus 4y minus 11 is equal to 0. Next, let us have the vertical hyperbola with center HK. And these are the formulas in finding the vertices, the equations, and the length, as well as the endpoints. Let us have now the graph of the vertical hyperbola. This point is the center with coordinates HK. This is the vertex with coordinates h, k plus a. Another vertex, h, k minus a. This is the focus, h, k minus c. This is the other focus, h, k plus c. This is the co-vertex, h minus bk. This is h plus bk. And you have the asymptotes. And from here to here, it's the latus rectum. And here to here is another latus rectum. Let us have an example. Determine the coordinates of the foci and vertices, the endpoints of the transverse axis, conjugate axis, and latus rectum, and the other parts of the hyperbola. Given the square of y minus 3 over 285 minus the square of x minus 4 over 9 is equal to 1. And this is now the table of values, wherein h is equal to 4, k is equal to 3, a is equal to 5, b is equal to 3, and c is equal to 5.83. So the vertices, we have 4 and 8. So the vertices, we have the coordinates 4, 8, and 4, negative 2. Foci 4 and 8.83, and 4 with negative 2.83, and so on. So let us have the graph. This is now the location of the center. The center is 4, 3. This is the vertex 4, 8, 4, negative 2. This is the latus rectum. And the length is 3.6. These 4 points here are the intersection of the vertices and the co-vertices. Then draw the asymptotes with the equation y minus 3 is equal to 5 over 3 times the quantity x minus 4. You may simplify the equation or not. And these are the endpoints of the latus rectum. This one, this, and this are the endpoints of the latus rectum. Next, let us have now the application of the hyperbola. Hyperbolas have real-world applications in many fields such as astronomy, physics, engineering, and architecture. The design efficiency of hyperbolic cooling towers is particularly interesting. This is how cooling towers look like. Cooling towers are used to transfer waste heat to the atmosphere and are often touted for their ability to generate power efficiently. Because of their hyperbolic form, these structures are able to withstand extreme winds while requiring less material than any other forms of their size and strength. Let us have an example. The design layout of a cooling tower is this one. The tower stands 179.6 meters tall. The diameter of the top is 72 meters. At their closest, the sides of the tower are 60 meters apart. Find the equation of the hyperbola that models the sides of the cooling tower. Assume that the center of the hyperbola, indicated by the intersection of dashed perpendicular lines in the figure, is the origin of the coordinate plane. Round final values to 2 decimal places only. So the height of the cooling tower is 179.6 m. From the center Until here, that's 79.6 m. And this is 72, the diameter. And the sides of the tower are 60 m apart. For the solutions, let us have to find the value of a squared first. So let us recall the length of the transverse axis of hyperbola is 2a. So in this figure, from here until here, that's equivalent to the measure of 2a, and that is equivalent to 60. So 2a is equal to 60. And divide by 2, so a is equal to 30. And square a, so 30 squared is equal to 900. So the value of a squared is 900. Next, we have to solve for b squared. Now we assume that the center of the tower is at the origin. So the standard form of the horizontal hyperbola is x squared over a squared minus y squared over b squared is equal to 1. So using this standard form, then we have to simplify the signs. So multiply this by a negative 1. So what is left is y squared over b squared. Multiply this by 1. We have negative 1. Multiply this by 1. So then we have to simplify the signs. Multiply this by a negative 1. We have y squared over b squared. And this by a negative 1 is negative 1. Here by a negative 1, it's positive x squared over a squared. And then after that, we have to isolate b squared. B squared is at the denominator part. So, simplifying the equation, we have to rearrange first. We are going to place negative 1 at this side. Let's continue our solution. We have to express this whole part here into fraction form. So what we have is x squared over a squared minus 1 over 1. And then apply cross multiplication. So we have b squared times this and y squared times 1. So we have only y squared. And then divide both sides by x squared over a squared minus 1. So we have here and here. Then cancel. So what we have is b squared is equal to y squared all over x squared over a squared minus 1. So this is the algebraic value of b squared. So after this, let us use this algebraic value and substitute the values of x and y. Our x value can be represented by the radius of the top, or which is equivalent to 36 meters. This is 72 as the diameter, so half of that is 36. The y value is represented by the distance from the origin to the top, which is given as 79.6. So from here to here. So substitute 79.6 to y and then you square over x is 36, so 36 squared over the value of a squared is 900 minus 1. Take the value of this and the result is b squared is equal to 14,400.36. The sides of the tower can be modeled by the hyperbolic equation x squared over 900, this is the value of a squared, minus y squared over 14,400.36, which is the value of b squared, is equal to 1. Do you have questions? If there is none, see you next time. Bye!